All right, it's recording. All right, exercise 2A, B, C, D, E. The reason why we're combining it is because it's all year 10 and year 9 revision. These are the things you must know. You need to know the formula for midpoint. How do you find the midpoint between 2 points? How do you find the distance between 2 points? How do you find the gradient? How to find the equation of a line? And then parallel and perpendicular. What I just described there is your exercises, 2A, B, C, D, E, all broken up. Okay, so this is E. I think this was D. This might have been C, and then 2AB is somewhere in between those two there. Okay, so that's how you know which one to focus on. But instead of doing the exercise, it's too many questions. That's why we gave you a worksheet. So go through the worksheet. If you're finding the questions are hard, you can go back to the exercise to find where you can get extra help. And if you can't figure it out, send me a message. I'll make a video personally for you or for the class so that other people can learn as well. Okay? All right, so let's start off. Let's do a recap. So the first box here, let's recap. Hands up if you remember what the midpoint formula is. What's the midpoint formula again? You got 2 points. How do you find the midpoint? Anyone know? Hands up. All right, good. Let's copy this. Here we go. So midpoint formula is if you have a point A, B, and you got another point C, D. So those are 2 points. If you want to know where the middle is between those 2 points, this is the formula. Capital M for midpoint. And it is, there's always an X and Y coordinate, right? So this is what you fill in. It is A plus the C. So A plus the C. So the X and the X together. So X1 plus X2 divided by 2. So you're finding the average between them. Then to find the Y coordinate, where's the middle of the Y coordinate? It's the addition of the Y coordinates. So it'll be B plus D divided by 2. Now in your textbooks, they won't write it that way because I wrote A, B, C, D just to make it easier for you, but your textbooks would write it like this. I'm just going to make this a bit smaller so it fits nicely in the bracket there. Your textbooks will call it X1, Y1 and X2, Y2 because that's the proper notation. So the notation is that X subscript 1 just means that's the first X coordinate and then the first Y coordinate corresponding to it. And then the second X coordinate and then the second Y coordinate. So that means the formula will slightly be different. It will just be M is equal to, so this is what your textbooks would write, X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. Okay, but I'm writing it as A, B, C, D just because I think a lot of students relate to the letters now rather than subscripts. Okay. All right, let's go to the next formula. Anyone remember the distance formula? D is equal to, hands up if you remember this one. Yes, Milena.
Square root x1 minus x2, like in a bracket.
Yeah.
And the square symbol.
Good.
And then plus bracket y2 minus y1 bracket square.
Good. I'm just going to fix this. I just wrote it wrong. It's 2, 1. Okay, this is actually, the proof to it comes from the Pythagoras' theorem. That's really just a squared plus c squared. If you remember from Pythagoras' theorem, a squared plus b squared, and the hypotenuse is c squared, right? Because distance between 2 points, you're really just finding, this is your a, that's your b, and that's your c. So all they're doing is they're just saying, find the x coordinates, the distance, find the y coordinates, square these two, and then how do you find c? Well, you got a square root. That's where the formula comes from. Okay, it comes from your Pythagoras' theorem. But you don't need to know that. It's just me describing where it comes from. So it helps you remember. Okay, so this is your formula for the distance between 2 points, not the midpoint. So between 2 points, how far, what's the length? That's the formula there. Okay, so this would be your x1, y1, for example. So that's your first point. And your second point could be x2, y2. Then plug it into this formula, subtract the 2 x's, square it, and then subtract the 2 y's, and then square it. That's how you find a squared plus b squared. All right? All right, next one. Now, this is the big chunk that actually leads into a lot of theories, and that's why in year 9, when you first begin, this is where a lot of students give up, usually. And if they continue, they struggle in year 10, if they struggled in year 9, and then they struggle again in year 11. This is how I know. Gradient. What's the formula for the gradient again? We normally use the letter M. M is equal equal to, what is it? There's a lot of formulas that you'll know, but there's two key ones that I want you to know. Anyone know? Hands up. Rise over run. Very good. I'm just going to move this up because I'm going to write quite a bit. Let's make it smaller. Rise over run is one of them. So you got rise over run. So that's the first theory we try to describe to you because y is the vertical axis, so hence it feels like a rise. X-axis is like the horizontal plane, so hence why we say run, because it helps students to understand. What's the formula again? So rise over run, if you count how much you go up and how much you go across, you do the ratio, that is your gradient. What's the formula again? Very good. This might be similar to your distance formula. Have a look. There's y2 minus y1. There's also x2 minus x1. So that might help you relate the two because you'd really just find the distance vertically and horizontally. That's what you're doing. Okay? So gradient is just the ratio of how much vertical versus how much horizontal. That's what a gradient is. But there is also one more special formula. Now this one is in the textbooks, and I think it was for year 11, but it might have been in the year 10. I feel like I did teach it, but just in case. Anyone know? It's to do with the angle. Something to do with an angle. Very good. Write this one down. Tan of an angle is actually equal to the gradient. You know when you're learning in year 9 trigonometry and you type on your calculator tan of 30 degrees, whatever it is, what you're actually doing was on your calculator, you were working out the gradient of that line. So if you type, for example, tan of 30 degrees, what that really means is you're actually finding, because remember, what's the ratio for tan again? Sokotoa? Over A, so it's opposite divided by adjacent, yeah? Now notice, if I drew a triangle and I drew an angle here, opposite's over here and adjacent's over here. But O, isn't that just your vertical? That's your Y. That's your Y values. So Y divided by A, which is X. Y on X is rise over run. That's why tan of an angle is the gradient. So when you say tan of 30 degrees, you know what you're really doing in your calculator? You're saying this. When it's 30 degrees, right, you're saying this angle, this line, the gradient, the steepness of this line, when you type in your calculator, whatever the answer is, that's the gradient. That's M. Because you're doing O divided by A. That's the same thing as saying rise over run. That's tan theta. That's what that means. Okay? And that'll become more useful when we get to term 3, circular functions. You start to learn how to sketch this graph as well. So what does a tan of theta looks like? Okay, but that's the theory. All right, so that's one that you'll find one of the questions I've got set up for you that if you didn't know that property, you won't be able to solve that question. All right, so that was a big one there. And we use that all the way for differentiation term 4. That's key. Gradient, year 9, year 10, year 11. Now, general equation of a line. What is it again? Y equals M, mx plus c, mx plus c. Write that in. So you'll have an exercise. I think this is exercise 2D, where you have to find the equation of a line. To find the equation of a line, there's only two things that you must find. M and C. So what does M stand for again? Gradient, which is what we just talked about. So that's why that was the previous exercise. Yeah, so exercise, I think 2C, works on gradient for you to find M. Once you know how to find M, what's C again? Y-intercept. Now, how do you find the y-intercept again? What's the theory? You let x equals 0, because we know on the y-axis, if you pick a point, it's always 0 and then whatever the number is, right? Because if you pick any point on the y-axis, it's always 0 first, and then y. That's why we say let x equals 0. These are your two key things that you need to find the equation of a line. So we'll do some examples later so you can see. And your last property to remember, parallel, perpendicular. Anyone remember? So if two lines are parallel, how do we know if two lines are parallel? So if I gave you y equals 2x minus 1 and y equals 3x plus 1, are these two parallel? All right. Is it now parallel? How do I know it's parallel? What do you look for? Same gradient. Because it's like drawing the table right now. If I had to draw two lines, if I drew a line like this, that's a steep line. If I want it to be parallel, I have to draw exactly the same angled line. True? Because if I drew a flatter line, those two are going to intersect eventually. True? Because if I drew a line that looked like this, that's flatter, they're always going to intersect. So if I want it parallel, I have to draw exactly the same line in the same gradient. That's why we say if the angle or the gradient or steepness of the line, if it's the same, they're going to be parallel. So how do we know? Just look for the gradient. This is 2. This is 3. So for sure they're going to intersect because they're running at a different rate. Eventually they're going to intersect each other. So your property here is you must write, for parallel lines, the gradient of one equation has to equal to the gradient of the second equation. M1 has to equal to M2. Okay, so that's one of the first properties. And that will then look like this. So you get two parallel lines. Perpendicular means that they will cross at 90 degrees. How do you know if they'll cross at 90 degrees? What's the property? Yes.
The product of their gradient is -1.
Good. M1 times M2 equals -1. This is exercise 2E, I think it is. Okay, so if you're looking at that and you're like, oh, I don't remember that. We did that in year 10. We did it in year 9 as well. Those are your two properties that you need to be familiar with. So if I zoom out a bit, that's what 2A to 2E is. So anything that I just described, and if you're like, oh, I have no idea what it is, then you know which exercise to go back and practice. Okay, so that's what I mean. This is what you must know for 2A to 2E. Next lesson, I'm moving on to 2F, and I'm assuming that you know these properties, or at least you have the notes to utilize them. Okay, but you must memorize that. Okay? All right, let's do some examples then. So if that's the theory, that's the formula. Let's do some examples so that you can consolidate that theory. Okay, so the worksheet is more questions. I just picked out a few. Yeah? Here we go. Let's have a look at this one. Let's do an easy one. So I picked an easy, nice whole number one. If you did the textbook, they'll have fractions and have decimals, but same theory. Find the length. So when you see length, that's distance formula and midpoint. You got the two formulas. Look at your notes. Here we go. Let me learn some names while I'm at this. Where's my compass? All right. Let's pick from here. Let's go. Lucky. Is Lucky here today? Lucky. What's the midpoint formula?
M equals A plus C over 2 and B plus D.
Okay, good. The proper formula again, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, right? You got 2 points here, Molly?
Oh, I was gonna ask, are you meant to like using the fractions or do you like
If the answer simplifies to a fraction, leave it as a fraction. If it's a whole number, leave it as a whole number. So 3 over 1, simplify it down to 3. If it's a decimal, don't write decimal, leave it as a fraction. Fractions is normally considered exact values. If you change it to decimals and it's recurring, they won't accept that. Okay, so unless they ask you to do it in decimals. So here's my 2 points. You've got 1, 2, and you've got 5, 2. Doesn't matter which one's the first point or second point, so I'm going to label it. I'm just going to call this x1, so that means this is y1. Then this must be x2, and that's y2. So according to the formula, my A, first x coordinate, is 1, so it should be 1 plus, what's my C? 5, very good. It's the second x coordinate, right? So plus 5 divided by 2. B is my first y coordinate, which is 2, plus my second y coordinate is a 2 again, divided by 2. Let's go. 1 plus 5 is 6. 6 divided by 2, we know that's 3. And then 2 plus 2 is 4. 4 divided by 2 is 2. Okay? So far, so good? All right. Next person. Kai, what's the distance formula?
So in the brackets x2 minus x1 power 2
Good.
plus another set of brackets y2 minus y1 power 2.
Beautiful. That's my formula. You got your 2 points. Here we go. Let's fill it in. Square root. Notice how I do my layout. I do it purposefully as well. It's question, method, answer. I always have an approach, then I have the method, then I have my answer, and it's a vertical layout. I never do it horizontal, do it vertical. Okay? Horizontal means something different. So you want to stick to, it's like doing coding. It's a vertical entry. Yeah? So here I would then do, what's that? X2 is my 5 minus 1 squared plus y2 is 2 minus 2 squared. Let's see what that works out to be. 5 minus 1 is 4. 4 squared. What does that give me? Let's go with Christina. Who's Christina? Christina? 5 minus 1 squared. 16. Very good. 4 squared is 16. Plus, and then over here, 2 minus 2 squared. Can I please have, is this Sean here? Who's this Sean? Oh, Sean, yes. 0. And so that gives me 16 plus 0 is 16. So root of 16 is equal to, what can I please have? Let's go with Anthony. 4, that is correct. Now, be careful. Because this is distance, it's always going to be a positive number because you can't have negative distance. But when you square root a number, what do you have to remember again? Plus minus. Okay, there's usually, so later when you get to quadratics, chapter 3, when you do a square root of a number, there's technically 2 answers there. It's meant to be plus or a negative 4. Because negative 4 squared still gives you 16, and positive 4 squared still gives you 16. So when you do the inverse, which is root of 16, it could be positive 4 or negative 4. So in an exam, in year 12, or even year 11, when you get to this question and it's like application, they say distance, you should write plus minus 4 first. Then you say, since distance is greater than or equal to 0, therefore distance must equal to positive 4. That in year 12 is worth 1 mark. Okay, so that's called a justification mark. That in year 12, they do want to see that you knew was a plus minus, and then they want to know that you know the distance cannot be negative and you don't need to justify it. So that extra step in year 12 matters. In year 11, I'll be teaching you. So I may not penalize you. I might just took it across, tell you, but I won't take off a mark, that kind of thing. But in year 12, that's how it's marked. Okay? All right, so that's the first one. So that's exercise 2A. If you did 2A and 2B, I think that's roughly what you need to practice and play around with. There's obviously some problem-solving questions in there too, but that's what you're essentially doing, using the formulas, yeah? Let's go on to the next one. So this one, I try to combine gradient and then finding the equation of line. So I did it all in one example. Otherwise, you do too many examples with me. So here, example 2, find the equation of a line. So when they say equation of a line, you should be thinking of the general equation. What's the equation of a line? Can I please have? Let's go with Artie. What's the general equation of a line? Good. Mx plus c. You need to find the gradient and you need to find the y-intercept to find the equation of this line. They already told you the 2 points. They told you it's 4, 3, 8, 12. So using your formula to find m again, m was equal to, and you had your formulas that I gave to you, y2 minus y1 over x2 minus x1. So what does that equal to? You label their own coordinates, up to you. I will call this x1, y1, x2, y2. So according to that, I should have 12 minus 3. Some students make a mistake at this point because we always do x before y, and they do 8 take away 4. Don't do 8 take away 4 on the top. It's the y's first. Yeah, so rise over run. So it's 12 take away 3 and then 8 take away 4. I'm just following what I labeled here. Let's work that out. 12 take away 3 is 9. 8 take away 4 is 4. Don't change that to a decimal. Leave it as a fraction. By the time you know methods, your algebra has to be strong. It also means your fractions have to be strong. So if you're not strong at fractions, learn to practice writing fractions. Don't avoid it. Okay, because examiners know next year you'll see a lot of fractions. You just put it left, right, and center. So 9 over 4, that's my gradient now. So that means the equation of this line, I now know this. It's y equals 9 over 4 is my m, x, but I still don't know what my y-intercept is. Okay, so how do you find the y-intercept? What do you do now? Sorry, your name was? Zoe. Very good. So at this point, what do we know about this equation so that we can solve C? The only things that they've told us was it's a straight line and it passes through 4, 3, and 8, 12. What that means is when x is 4, you sub 4 into the equation, the y value should be 3. That's what you're saying. Or if you sub 8 for x, then y should be 12. So that means here, in this equation here, even though I don't know what C is, I do know one thing. That if I subbed 4 into x, y has to be 3. Or if I subbed in 8, then y must be 12. That's the only thing I know about this equation. Okay? So that's why we sub one of those points. What's a common mistake? Students subs x equals 0. Why? Because we keep saying, how do you find the y-intercept? They say let x equal 0, and they just do that as a mantra. They're not thinking. If you're thinking about it, I don't know what, even if I sub x equals 0, it doesn't give me anything. It just gives me y equals c. So if you really think about it, the only thing I knew was coordinates 4, 3 and 8, 12. Those are the only two things I knew. Yeah? So sub either which one would you choose? I would choose the one with a smaller number. So out of the two, I probably would have done 3 and 4. Okay, so when you sub, was it 3, 4 or 4, 3? 4, 3, yeah. So sub x equals 4, this is 3. So 9 on 4 multiplied to 4, adding on c. Now this is where some fractions for some students you use a calculator for now. Later on you have to be able to do this by hand. What's 9 over 4 times 4? 9, very good. Some students will still do 9 over 4 times 4 over 1. 9 times 4 is 36. And then 4 times 1 is 4. And then 36 divided by 4 is 9. The proper way is that you should have done simplified multiplication. So 4 divided by 4 is 1. And so 9 times 1 is 9. And then 1. So you should know it's 9 from the beginning. Okay? So that's just a bit of year 7 to 9 mathematics there. So 4 divided by 4 should cancel out to be 1. So 9 times 1 is 9. Plus C. And then finally, we want to know what C is. So how do I get C? What do I do? Balance the equation. What's the next technique? Let's go with Ben. Very good. That's a positive 9. So if I said opposite of positive 9 is minus 9. Minus 9 on both sides. 9 take away 9 is 0. So that cancels out. I've got C left over. And then 3 take away 9 is negative 6. So what's my equation? This equation here, if you typed on Desmos. Hands up if you used Desmos before. It's a good tool. It's kind of like your graphics calculator but on your computer. So y equals 2, 9 over 4x minus 6. That is the equation of this line. If you found that difficult, there's an exercise for it. Okay, so you can work through those questions there. Now, there was a second bit that we didn't do. It says, and determine the angle it makes with the positive direction of the x-axis. What is that trying to say? That's what I mean. That was in your year 10 textbook, but it's also now more pronounced in your year 11. You see that line that I've drawn for you in advance? It crosses through 4, 3, 8, 12. We now know the gradient's 9 on 4. But the angle that it creates with the positive direction of the x-axis. So this is the x-axis. That's the positive direction. This is the negative direction. So when they say what is the angle this line makes with the x-axis, that's what they're referring to. They're saying, what's this angle? That's what they're asking. They're saying that if you draw that line there, what's that angle there? Now, I gave you a formula before. For the gradient, and it has an angle, what's the gradient equal to again? Tan of theta. There's the angle there. What's the gradient? 9 over 4. We already figured it out. We said n was 9 on 4 before. So you're really doing, back to year 9 maths again, 9 on 4 equals tan of theta. I don't want the tan. I just want to know what the angle is. How do you get rid of tan? What's the opposite of tan or inverse of tan? Tan inverse, if you've forgotten. It's a tan with a little negative 1 on your calculator. So you're going to do tan inverse on one side. Whatever you do to one side, you do to the other. So on your calculator, you'll be typing tan inverse of 9 on 4. So tan inverse of tan will cancel out because they're opposites. And then you end up with theta, which is the angle, will equal to whatever tan inverse of 9 on 4 is. Now I'm going to bring up my calculator. Is that so? 66 point... Actually, I got my own calculator here. 10 inverse of 9 over 4. Yes. It's about 66.03 degrees or 0.04 degrees. Okay? So just check that you got that. Later on, we'll go into minutes and seconds, but for now, just write it as 66.04 degrees, roughly. Okay, and later on, it will get more confusing because the angle could be an obtuse angle. This is clearly an acute angle, so it has to be here. So that's why I know is 66.04. Okay, but that's for a future thing. But there you go. That is the exercise to do with finding equations of a line. And your last one, same thing, equations of a line, but parallel perpendicular, using the two properties I just gave to you. Here we go. Find the equation of a straight line. So again, every time you see equation of a straight line, you should be thinking of y equals mx plus c. You just need to find m. You need to find c. It tells you that it passes through the points 6 and negative 10. So they're telling you that when x is 6, y is negative 10. That's what they're telling you. I don't know what m is. I don't know what c is. But they told you it is parallel. So whatever this line is, I'll just draw a random line. That line is parallel to y equals 3x plus 1. So using what you understand about parallel, if they're parallel, what's one thing we know? Gradient's the same. They have to have the same gradient. So from the get-go, for parallel, m1 has to equal to m2. Since I know that line has a gradient of 3, this is over here, that's a gradient of 3. That means this line has to have a gradient of 3 as well. So that's why I know straight away m2 is equal to 3. Okay, so if you're a bit confused by that, that means you got to go back and practice your parallel perpendicular. So what does that mean? I now know the equation is y equals 3x plus c. I don't know how to find c. And the same thing as you did before, and I think it was Zoe before that told us what to do. So what do we do here now? How do I find c? Yes, Luke? You forgot? Yeah, that's the only thing we know. So this is the line that we're trying to figure out. What have they given us? The only thing they've given us is 6 and negative 10. It's like a puzzle. They're saying, well, if x was... Sorry, what's going on? X was negative 6. Was it 6? 6. And then y is negative 10. That's all they told us. So you sub it in. This is why you use the points that you have. You use the only things you know. You sub in 6, negative 10. And then this is the equation you get. You'll get negative 10 is equal to 3 times 6 plus c. You can now solve for c. So here we go. Was it 6, negative 10? Yeah, it is. All right. 3 times 6 is 18. Negative 10 plus c. And now it's up to you whether you can solve this. Can you see why everything you've done from year 7 all the way to year 10, that's how I know. If you lay it out, I'll know. Are you struggling with fractions? Are you struggling with solving? That's how I tell how strong you are. So from this step, solving for c, minus 18 on both sides. And I'll know if your negatives are terrible as well. Negative 10 minus 18, what is that? Good. Not negative 8. So the equation for this line must be 3x minus 28. That is the answer if it's parallel. Perpendicular follows exactly the same technique. The only difference is the property is different. So again, it's perpendicular to the line y equals 3x plus 1. We're trying to find y equals mx plus c. What do we know if they're perpendicular again? What was the property that, I think it was you that gave it to us before. What was your name again? Massey. Massey said something about perpendicular lines. What was the property again? Molly? Good. So right now I know this is my gradient. M1 is equal to 3. But we said that M1 times M2 needs to equal to negative 1. So 3 times what will equal negative 1? And for some of us, that could be difficult, but that's why all you had to do was solve it. If you did 3 times m equals negative 1, how do you get m? divide both sides by 3. Because that's times 3, so 3 divided by 3 cancels out. M equals negative 1/3. So you can see there's a lot of reliance on algebra, solving everything that you did in year 9 and 10. Yeah? So that means I now know the gradient here, if it's perpendicular, it needed to be negative 1/3. I've got the x, and now let's go back to Luke again. So what do you do now? I've got this equation. Very good. That's the only thing we know. We know that pass through when x is 6, y needs to be negative 10. So here, this is where you then say sub, if x is 6, y needs to be negative 10. So that's why you get negative 10 equals to negative 1/3 times 6 plus c. Let's go. There's a bit of fractions here. What's negative 1/3 times 6? Very good. Negative 6 on 3 is 2. Or you can say 6 divided by 3, that's 2 and that's a 1. So that becomes negative 1 times 2 is negative 2. Find c, add 2 on both sides. Negative 8. Anywhere in that, you can make a mistake. The more consistent you make those same mistakes, that's how I know how strong your negative numbers are, how your solving is, your bod mass and all that. That's what I know. So if you don't show me any layout, I know where you're at 2. Because it means that you're either skipping steps because you're really good or you're skipping steps because you're really bad. It's one of the two. Okay? So there we go. So what's the answer for the perpendicular line? If you typed on Desmos, y equals to negative 1/3 x minus 8. This would have been the perpendicular line. You'll see that it'll cross perpendicular with 3x plus 1. That there is a summary of what you need to know for 2A to 2E. Okay, so normally I don't actually teach this, but because I don't know you guys from last year and all that, so I just thought I'd run it through with you. Usually I just give you the worksheet and then say it's revision from year 10. Okay, but we don't always get this time to do this. Okay, so usually I would just run it and just assume that you know all this. Okay, so some of the things I did before, like the crossing off, that's me trying to introduce and kind of get a gauge of what you know. The stronger your algebra, then the faster I go through my calculations. Okay, but for now, that's what 2A to 2E is. Make sure to try to keep up, which means go ahead. Okay, if you can go ahead, you can go past 2E. Just make sure this background is good. Just keep going forward. Don't wait for me. I'm pretty sure I'll catch up. Okay, because I'll just keep going really fast. You just keep going forward. Okay, but that's it for our lesson today. I'm going to stop the video.